This is a brief update on my second Class D H-bridge switching board. So there's no pulse width modulator on this board that would have sat over here. This is just the FETs in the H-bridge configuration and an IXDD 614 driver here. It's connected to this VFO with the upside down display. This is not the one that's mounted in the transmitter. This is another one which I built as a kind of a side project. So usual configuration, and clock zero comes out here, some amplification, little bit of filtering, and then a 74HC04 buffer to get a 5 volt square wave with a DC offset adjustment there that allows you gives you a little bit of control over the duty cycle. So that's a 5 volt peak to peak signal coming around here onto the input of the MOSFET driver. Then the output of the MOSFET driver is about 12 volts peak to peak, and that goes through these gate transformers onto the gates of the FETs. So I'll turn it on. So we're on 160. Power supply, that's the power supply to the drains. So that's the high tension supply. And I'll monitor the output signals. So the 12 volt circuitry is turned on. So all I need to do is to just earth the end of this resistor, and the Arduino will activate the drive. So here we go. So there's the output waveform. I'll just cycle between receive or standby and transmit mode. On a times 10 probe, it's showing 19 volts peak to peak, but it's not that much. It's 50 volts per division, so there's 50 volts there and a bit more, 50 volts there, and that's 100 volts, maybe 130, 140 volts peak to peak. There's no low pass filter, so there's nothing to smooth it. I reckon it's about 130 to 140 volts peak to peak, and I think what the scope is doing, it's responding to these leading edges here and seeing much more. So at about 140 volts peak to peak, 140 volts peak to peak is about 50 watts, so plus 47 dBm. If we look at the power supply, 30 volts, it's the FETs are drawing nearly 2 amps, so that's about 60 watts in, about more or less around 50 watts output into the dummy load, which is getting it's getting warm, just nicely warm, so around about 50 watts. So 50 watts from about 58 watts in, so it's pretty good efficiency. Now this heatsink is cold, the driver is cold, and I'll just carefully check the temperature of the FETs, and they're all cold. Not exactly cold, but none of them are warming. I would say none of them are warm to touch. So this module seems to be working pretty well as expected.